Hello and welcome to the Daily Space for today, Tuesday, January 21st, 2020. It's been a wild few days. It was supposed to be a holiday weekend, but apparently that doesn't stop amazing things from happening. As promised, today's episode will take a deeper dive into the content of our galaxy's central region. But before we do that, we do have a couple of news items to highlight. First off, after, multiple weather delays, and pardon me while I lean, I'm still having some technical difficulties getting things to switch over to showing you slides. First off, after multiple weather delays, SpaceX was able to launch a 3-time used Falcon 9 from Kennedy Space Center's Launch Pad 39A. Atop this rocket was a Crew Dragon capsule containing 2 mannequins and a whole lot of sensors. This wasn't a normal launch. This was the in-flight abort test many of us have been waiting months to see. Less than 2 minutes after launch and after sustaining max Q, that's the maximum dynamical force that the spacecraft will encounter, SpaceX had their Falcon 9 just turn off. This had 2 effects. As planned, software on board correctly processed sensor and system data to recognize the problem and released the Dragon crew capsule and fired its Draco engines to get it the expletive out of there. The next thing that happened was the unstable rocket proceeded, as planned, to explode in a dramatic way. These are just some of the images of that exploding rocket, which kind of actually looked like a tulip. The jettisoned capsule accelerated away with a maximum acceleration of 3.4 times the acceleration of gravity. This is significantly easier on the body than what astronauts experienced during a necessary abort of a Soyuz capsule in October of 2018. After reaching a maximum altitude of around 25 miles or 40 kilometers, the system began a safe journey home, with all parachutes deploying as planned and a safe splashdown into the ocean. This was a successful test and prepares the way for a launch sometime this year. And in fact, we already have that Crew Dragon capsule back in port in Cape Canaveral. In a press conference following the abort test, there was a clear attempt to maintain a single narrative between NASA Administrator Jim Bridenstine and SpaceX CEO Elon Musk. And Musk stated they'd agreed on messaging prior to appearing roughly 15 minutes late on the press conference stage. Musk made it clear that SpaceX should have hardware ready to go by the end of February or at worst early March, and should be ready for a launch shortly thereafter. Bridenstine, on the other hand, stressed the desire for additional tests of the parachute system on the Crew Dragon and said that NASA is going to be rethinking how to use this new hardware and consider if they'd like to change their current plan to have a short mission to the International Space Station and instead have the astronauts stay for an extended period. That latter option would require additional training and would delay launch by an unknown amount of time. Many of us wonder why NASA didn't provide training for both kinds of missions, long or short, already, and some question if this is a delaying tactic to allow Boeing and its Atlas-launched Starliner a chance to catch up in development. Bridenstine was extremely clear that NASA wants to have multiple suppliers of human space launch services and continues to publicly back Boeing and United Launch Alliance. In December, when our daily space team visited Kennedy, we found that the information given during facility bus tours actually stressed these older companies and talked about how it would be Boeing that returned Americans to space from American soil. Since NASA is a government-funded agency, there is a complex set of politics behind every public message, and messages often are designed to keep the Congress people who write the budgets happy. As we watch the similarly politically motivated actions in the following months, we will be paying close attention to see if Boeing puts their capsule through the same tests and experiences on the same timeline of delays as we're seeing for SpaceX. We're a fan of a take it slow, test everything, and move forward boldly kind of approach. But we want to see fairness in how these two companies are allowed to advance their technologies. In other news, a bit further from home and, well, less rocket-based, a team of NAOJ researchers has published in the monthly notices of the Royal Astronomical Society the orbits of two outbound comets. And this isn't an image of either of those two outbound comets. I got my images out of sorts. Sorry, those are the outbound comets. Has published in the monthly notices of the Royal Astronomical Society the orbits of two outbound comets that it's determined could easily be two more alien objects caught passing through our solar system. It's also possible that these are objects from the Oort cloud that were put on escape trajectories through some kind of an interaction or perturbation. This has me thinking. Growing up, I, and probably many of you, learned that comet orbits come in basically four varieties: short period comets, long period comets, parabolic, hyperbolic. All these orbits, well, two of these kinds, the parabolic and hyperbolic, those send comets flying out of our solar system. While 2017's Oumuamua was the first definitively extrasolar object to be observed, what if we've been observing comets from other solar systems on a random basis for as many centuries as we've been observing comets? The rapid rate at which we've gone from the discovery of Oumuamua to recognizing multiple objects of possible extrasolar origin makes this question of particular interest. And I look forward to seeing how our understanding of the origins of comets changes in the coming years. In other comet news, and building on last week's announcement of phosphorus in comet crusts, we are now learning that comets are rich in ammonia ice that trap nitrogen into hard-to-measure solids. These results come from the Rosetta mission and a Bernese instrument that sampled the material around the spacecraft to directly measure the chemical compositions. Earlier research looking at Halley's Comet in spectra of the coma turned up significantly less nitrogen than was expected. Solid ammonia, however, wouldn't have been measurable in that data from the Giotto mission. This new data with Rosetta gives us one more piece of evidence that comets, and likely asteroids as well, impacting the Earth, brought with them all the building blocks of life. And that's just kind of cool. And that's really all the news we have for today. But we do want to take that planned drive into the center of our Milky Way galaxy. In recent months, we've seen a series of discoveries add nuance and detail to our understanding of the inner few parsecs of our supermassive black hole's surroundings. That supermassive black hole is Sag A star. We've known since the late 1990s that our galaxy has a massive black hole in its core that is 4.3 million times the mass of our sun and is orbited by stars that get as close to this black hole as 970 astronomical units. That's roughly 20 times Pluto's distance from the sun, which is a pretty small orbit for a star. This understanding comes thanks to the amazing work of UCLA's Andrea Getz, who created a new technique for the Keck telescope that is able to achieve extraordinarily high-resolution ground-based images of the star-swarming Sag A star. As her team and other astronomers have followed the motions in the inner galaxy, they have revealed a cluster of young stars with ages measured in millions rather than billions of years. While this team has been able to see individual stars, they've only been able to see the largest stars. And it has been suspected that there is a large population of what are called S-cluster stars that orbit in this inner region, with more numerous smaller stars being beyond what our telescopes can see. Well, last week we got new information that there is a population of what they are calling G objects, gaseous objects. These objects orbit that supermassive central black hole as well and are much larger in physical size, but not larger in mass. They appear to be gaseous and sometimes get tidally distorted as they pass in their closest approach to that supermassive black hole. These objects are now thought to be, well, the remnants of binary systems that got disrupted and brought closer and closer together as they interacted with the gravity of that supermassive black hole. These prior binary systems that have merged to share a common envelope, well, they're as numerous in number as would be expected from a star cluster with binary star systems. So instead of counting individual binary star systems, we're counting the remnants of binary star systems. And these systems are having gas and dust stripped off of them that at some point is going to get plunged into that black hole's event horizon, releasing high energy radiation. Now, what's particularly awesome about this star cluster is it didn't necessarily form right where it is, but rather it formed outwards and was on an unfortunate orbit through whatever past interactions it had the misfortune of suffering. And that orbit sent it careening in towards the center of our galaxy, where things got dynamically mixed up as different objects at slightly different velocities, slightly different distances from the black hole, and each were affected in a slightly different way. This mixed up the stars, sending them out of the standard orbit of a star cluster and into a wild halo that we are now able to observe. This is an amazing set of observations. And while this is all awesome, the best is really yet to come. The Event Horizon Telescope has unreleased images of Sag-A star. Last April, this team released their image of the significantly larger M87 supermassive black hole. And in their field of view, both that black hole, which is further away but massive, and the much smaller but closer Sag-A star should have about the same angular size. Now, unfortunately, Sag-A star has been harder to process because the material around it is comparatively more obscuring and harder to subtract out of the images. But when that image finally comes out, it will expand out on this picture in new ways and in new details. And we can't wait to see that image. And that rounds out this episode. This has been The Daily Space. As always, we are a production of the Planetary Science Institute, and we are produced by Susie Murph. We are made possible by your generous contributions. Your subs, your bits, your patronage over on patreon.com all keep the lights on and keep everything going. So thank you for all that you do, and I'm now going to hang out and answer your questions. If you can please precede them with that purple circle with a purple star in them, it will make it much easier for me to find them. So I'm going to scroll up through the questions and see what I can find. Let me see. It's good to see new faces out there today. We do have all the doggo here. Oh, I'm sorry, Arnstro, that the intro music was a bit high. I need to get those levels adjusted. Hello, Wayne Johnson, and your highlighted text of awesome. Yeah, sorry for starting muted. I muted my microphone because right before going live, I was listening to the news. Don't do that. if you need to go to bed, I have learned I now need to listen to the news in the morning instead of in the evening. The world is literally on fire. And the Falcon did go boom in a explosive burst of fire that was good and on purpose. As Kerbal01 puts it, it blew it up real good. Let's see what else is in here. Wayne Johnson, thank you for the bits. Oh, hi. Okay, you will get it last. Here, that's for Malachi. That's for Malachi as well because I can't throw. That one was for Stella. Now you can come up. Here, there you go. Good doggo. So many more bits. Who do I need to thank? Thank you, Trekker Kev, and the way it goes. Thank you. Okay, Malachi first. Eddie. Okay, you are now on the desk. Here, Stella, come here. Any of you who watched our live coverage of the Falcon 9 abort test got to witness me using Stella as a space heater. The temperatures are finally starting to come up in southern Illinois, and I am not truly shivering as I was on Sunday morning. She's a good doggo and the perfect size to use as a space heater. Okay, scrolling up to see what else we have in here. Planetary Pan has new furniture. Enjoy your furniture. Let's see. So DPI 209 points out that price per seat as per NASA audit report for SpaceX is $55 million, Roscosmos is $80 million, and Boeing is $90 million. Orange Stro says today's outfit is the color of cosmic night wrapped in starlight. I feel like I must be green screening a bit. Sorry about that. I'm wearing a wool sweater. I'm quite warm, even if I am green screening a bit. Looking to see what other questions. Paranor is asking, covering launch tonight. One of us will be. We'll figure that out later. It's still early in my day. Kerbal's like, neat striped coat. This, I love this. I really do. This was a epic purchase I made last winter. We're not going to discuss how much it cost. It's by Patagonia. They have different colored versions available this year. And this one has survived being washed. It has not been dried because I like myself. It did get significantly smaller when it got washed. So if you find one, and they have them on the Title IX website, get it bigger than you need. Raj Luthra asks, will you be watching Star Trek Picard? Yes, but I'm a binge watcher, so I'm probably going to wait till the whole season is out. Gluten-Free Space asks, are these binary star systems remnants found around all large black holes? We don't know. This is the only system we can see in this resolution, in this level of detail. And so here's the thing, is what we're seeing is probably a temporary moment in our universe's history during which our particular galaxy has this young star cluster. Stars age. We're not seeing stars that are a billion years old in there. They could be there, but they'd be too small for us to see. It's only because there are young stars at this brief period in history that are huge stars die young, that we're able to see that this cluster is in there. So we don't know. So Veronica Cure asks, is there an easy way to find Sag A star? Only with a radio telescope. But if you look at the constellation Sagittarius, you're looking at the heart of our galaxy. It's in the teapot. Yeah, it's in the teapot. All right, so Ms. Brick Kitten, and I want to know, Miss Brick Kitten, are you going to get the Lego ISS model that's coming out? Comments. I saw a recent article saying Betelgeuse may have eaten a smaller companion. Is this what may be causing the current dimming? I haven't seen that article. As far as I knew, Betelgeuse was a single star. That doesn't mean that a new paper came out since I looked into this and that I'm not wrong. Data changes, our understanding changes. As we learn new things, as our technology allows us to see things we couldn't see before. I can't think of why eating a smaller companion would make it 25% dimmer, which is what it appears to currently be. But I haven't seen that, so I don't know. Send me a link. I'd love to read that. Tag me in Discord so I can find it, though. I'll often see notices come up in the corner of my screen as something cool that was said on Discord, and then I can't find it. Discord flail. So Broken Symmetry asks, are those young stars forming out of black hole event horizon crumbs? No, it's a pocket of gas that fell into the center of our Milky Way. It was probably happily on orbit and got disturbed by something else going on. Yeah, sorry, ours is Inc. trying to avoid politics. This is a place of science, and we're following the KISS principle, where in this case, it's keep it simply science. And if we talk about politics, it's like Boeing versus SpaceX politics. There's a lot going on in the world. Kerbal, the reason Starliner is more expensive than Soyuz is a significantly older design, and because it's been around for so long, even though it's not reusable at all, they've nailed production. So they've basically paid off all the development costs and are now just remaking with minor incremental adjustments over time, and that brings the cost down. Now, trying to get the cost that low really requires you to have a long-term, many times used rocket, or, as SpaceX has done, to reuse components. The only way to get cheaper than Soyuz is to reuse stuff. Now, the other problem that they're running into is Boeing's development was, well, they have a full bureaucracy going. It's an old corporation. It has large overheads. And it's been a delayed and hectic development process. So that also drives up costs. Yeah, it's not pretty. Oh, Paranor is saying Starlink was pushed to the 24th, so no launch tonight. Okay. Yeah, so for those of you who aren't aware, Starlink is going to be launching their, or SpaceX is going to launch their third series of Starlink satellites into low Earth orbit in just a couple of days. The rate at which they are launching these has a lot of people startled. And one of the concerns is we don't know if any of these satellites are going to have the optical darkening materials on them that was being tested on one of the satellites launched during the last launch just a couple of weeks ago. There's concern that SpaceX is basically rushing forward with this, ignoring the problems that they're creating for the astronomy community. Yeah. Once we know more about that launch, I'll have a thought-out discussion. DPI 209, I heart you right now. Writing, don't discuss what it costs when it keeps you warm. I'm one of those people that will buy something and then wear it for a couple of decades and then get sad if I gain weight because then I have to diet to make my old clothes fit again. I'm that person. If I had children, they'd be making fun of me. I realized the other day that all my current winter coats are at least 5 years old. CosmoQuest X, Raj Luther writes, has Mars 2020 rover got a name yet? I can't remember what's public and what's not on what's in my head on that, so I'm not going to answer. Sorry. I like the way Veronica Cure was like, I knew tea was important, referring to Sagittarius, and Arnstra is like, but not Russell's teapot. No, the center of our galaxy is not in Russell's teapot. This is true. Ms. Brick Hitton says, I will be looking at getting the ISS model. Ooh, and you're paying off your car. Congratulations. I remember that feeling. I have a 97 Jeep Wrangler, and when I finally paid it off, I was living in Boston, and it was like, oh my God, I can now afford to turn the heat up. Apparently being cold has been part of much of my adult life. So Arnstro is writing, it's also been argued that Starliner's cost included research and development that was over and above what SpaceX was asked to do. I don't know. Can you send me some links on that? I'd like to read more. Yeah, Veronica Cure adds in, Boeing is under scrutiny right now and has to use contracts signed during different economic times. There is a current problem where, especially with the Artemis program, Boeing is being asked to develop things, United Launch Alliance as well, and the message coming down from NASA is these are competitive programs. We're not going to pay for everything you do. You're expected to cover some of the costs. So these companies are essentially being asked to do labor for free for the opportunity to fly NASA to the moon. I have problems with that. Limperindle asks, how about radio darkening? So radio darkening of Starlink is, yeah, that's not a thing. The problem is we don't fully know once they're turned on what wavelengths they're going to be transmitting in. They are set to transmit in a specific band that has been allocated for satellite communications. That isn't to say that there won't be blur over or purposeful transmissions in other wavelengths. That was a problem that we had with the Iridium constellation of satellites, that it was purposefully using, well, radio wavelengths that it wasn't supposed to be, that stole the astronomical sky from astronomers until a contract or agreement, rather, was able to be worked out where iridiums would turn off over certain areas where astronomical observatories were located. Until they turn on, we won't know their impact on the radio sky. But in theory, they're simply blocking allowed bands. Okay, RevsMatt says, Astro Guys told me the next bunch of Starlink might be easy to see within days from the northern US and Canada. No verification. We'll know soon enough. We'll know soon enough. Ooh, Wayne Johnson has built a all-sky camera. Well, he bought the camera and he built the enclosure, and it's quite cool. He was showing it on the Astronomy Cast office hours the other day. And I look forward to seeing what you're able to image. All right. Yes, Miss Brickhinton, you can totally share an Instagram link. So there we go. It is so cold now. I was warm while I was moving. I'm now not warm. Come on, you can open. There we go. It's opening on a different screen. I have no idea what I'm looking at. Okay, let me switch this over to the other screen and see if I can figure out what I'm looking at. Nope, that was the wrong window I just grabbed. Let's try grabbing this one. There we go. I still have no idea what I'm looking at. Okay, Miss Brick Kitten, I need a description. I am so confused. Let me figure out how to get this better on screen for you guys. What is it? I don't see. Okay, so there's the words. Messing with the mock-up. I may need to reinforce the gear on the left. She wiggled at the end, but getting there. What? Oh, click the play button. Oh, that's cool. Now I understand. That's very cool. So this is a mock-up of the International Space Station that has motors added to it so that it can move the pieces as the actual International Space Station is able to move its pieces. That is kind of amazing. I have to admit, I apparently need a third cup of coffee because that white play button, my brain decided was like part of the black thing. Let's look at that again. Yeah, you can see all the solar panels moving. It's pretty awesome. So this is Barbie 1969. Barbie _1969. And this is why all of you should join the CosmoQuest Discord, because it's this kind of stuff that we love to share with each other. And thank you for the follow, human. Thank you. Thank you. All right. I'm cold. I'm sorry. That is apparently going to be the determining factor on how long I answer questions for today. I'm going to go upstairs and make myself some lunch, cuddle up with my heater, and then I'm going to record this episode. Trying to find everything. I may not do things quite in that order, and sometime between now and Thursday or Friday, I think Thursday is going to be Susie recording so I can get more coding done. I'm going to figure out how to get my Stream Deck working again. I don't know why it just decided, no, it's not going to work. But for now, I am going to roll the credits. There they go. I'm going to roll the credits and go work on getting some science out and warming up. So wherever you are in the world, have a fabulous... Wait, tomorrow is Annie for Rockets. Thursday is going to be Susie covering the news. Friday, I'll be back. And wherever you are in the world, have a fabulous morning, evening, or afternoon. And I'll see you on the other side. Bye-bye.